FIXME, is max pipeline index still needed? Now how would I know that? Plus I don't like this slash here. No, I want to work on the one at the bottom. Okay, so we have a max pipeline index, which is updated here, I guess, in update. Set to the maximum value that a pipeline index can be, and resize to that value +1. So this would be an index into graphics pipeline, so it doesn't even exist anymore. A Vulkan engine is kind of like a game engine based on Vulkan. Man, I have no idea what this thing is doing here. Shift left M range width. Characteristic range. Okay, I guess the range width is the number of bits that is needed to represent the whole count starting at 0. Or maybe not starting at 0. Yeah, starting at 0. Just subtract So we have a begin and we have a range. And then we separately, I suppose. An index is constructed by setting it to 0 and then calling this function for each characteristic range that was added to a pipeline factory with the current characteristic index. I think I get it. We have a pipeline index and we have a characteristic index. So it shifts the pipeline to the most significant bits, and then in the lower bits we add the characteristic index. And since we're going to create a pipeline per characteristic, then this becomes a pipeline index. Okay, it just needs a certain value before we call this. Still not getting it. Not enough explanation in the comments. It is because it is sorry, it is repeatedly called. So we start with 0, something is put into it, and then we go to the next characteristic. And what we are passing here is the maximum index for each range. So we're calling update for each. Well, that's not entirely correct. Oh yes, we're calling it on M characteristics. Okay, so we have a bunch of characteristics, and then on each M characteristic has a begin and an end. And I'm calling update, passing the maximum value for the maximum value of that characteristic, the range of that characteristic. So the first time this becomes the first time M pipeline index is 0, and we shift it M range width, and then we add the offset, basically offset relative to begin. And then for the next range, it is being shifted. And now we add the next one. And that kind of limits the number of characteristics drastically. It's probably not a bad thing, but okay. Well, certainly not, since it is an index into an array. So this thing becomes a size type large. We run out of memory long before that. But yeah, the whole thing is kind of strange. Nevertheless, I'll add what I just figured out. So mathematical notation, this means a range including begin, because it's a square bracket, and then up till, but not including M end. It doesn't really matter how many bytes. I mean, the bits, the number of bits is, I think the index is a wraparound the size type. Vector index, the size type. So on my machine that's 64 bits. But, well, that's a bit much, right? So. And now we have to say these bits here are a certain range, and then I need another character. Let's say few here, and then a bunch here, and a few here, and a bunch here, and they can have different sizes. So and then each is a call this and characteristic index. Let's call it the characteristic range index. Excusez-moi. Unbelievable. Will you believe they did hang up right after I turned off my mic? Tried to call them back, but nobody picks up. What the fuck? Impatient people. Well, you only see 0.01% of the code, and I'm pretty sure that this is not the most overwhelming part. I don't know which order do we add them in. The first one ends up here. Like I'm gonna call this range 1, and then we have here, let's say, range 1. This is range 0, range 1, and this is 2 then, and this is range 3. And so on until the last one, which happens to be 3, 4, 5, 6, 7, 8, 9, 10. In case anyone ever wants to count that. Okay, and then the value is the offset, right? So it is really characteristic range. Let's call it 0. Offset. Right, index type. I'll call it index type even though it's just an int. Strangely no. So this is how it is being stored. So by calling this repeatedly and in the order of the characteristics, that is, we start with calling it for characteristic range 0 and then 1, 2, etc. till 10. We end up with pipeline index being the maximum value, since index here is going to be the maximum value per range every time. That's the idea. Yeah, funny enough, it is indeed not being used. Not at all. This is a local variable, it's not being used. I'm having another call to update here. Calculate pipeline index. So in this case we have the pipeline index, and then we call update, and that updates the pipeline index. Okay, and that's how you have to read it. The pipeline index then is simply shifted and ORed with this value, which is the range counter of the current characteristic. So this runs from mbegin to mend, I suppose. Should be able to find that. Yeah. The start of the next loop, which is eventually stored in m characteristics, I think. No, it's stored in m range counters, I mean. Is, well, it comes from iBegin. So we started at iBegin and we ended iEnd. And then by calling update, we subtract iBegin again and use that as the least significant bits. And pipe index is then we're also doing this for the whole thing. Okay, pipe index just set to 0. Oh, right. And just a collection of all the range counters. But this one is kept. The FIXME question was, do we need the maximum value? So the real question is now, what is being done with pipeline index, apart from being printed? Yeah, it is being used. The maximum value the pipeline index can be is the max pipeline index. Here it is calculated, here it is being used. Okay, is this the only place that we're using it? Unfortunately, it is a public thing, it's not private. Or is it this one? It probably is this one. This one is private, that's good. Yeah, this is in Pipeline Factory. So this is a member of Pipeline Factory, which is private. So I can just jump to the header file and then have a look there, and it's not being used anywhere else. Don't even have an accessor for it. Oops. So this is definitely the only place then where it is being used, which means that it is passed to have new datum. Well, rather, have new datum is being passed, whatever type that is, which is constructed from a temporarily constructed pipeline, which has a second argument, something that is constructed from something that has a second argument is pipeline index. By now nobody knows the type anymore, but let's just look at it. So pipeline has a second argument something, and I guess that's this one, pipeline handle. Pipeline handle is here, and then apparently we're using aggregate initialization, which means it's this index. Pipeline index is simply stored in the handle. Okay, so we're storing this value in the in the handle of the pipeline. And then the question is, what is being done with it afterwards? That's not really clear, is it? So we're going to do the big trick, going to rename it pipeline index 2, and then afterwards we'll know exactly what that is being used. Yes, the time of day again. Can I do regular expressions here? Probably not. Because it was already saved now. I'm going to keep this page open, I think. So here it is used. Yeah, that's just where it printed. Not very exciting. No member named M pipeline index in vulkan double the pip. Here it is being used. I think I'm first going to rename all instances. And then we'll look at how they are being used. Yeah, what to do next? That is just printing. There is an operator bool declaration. It's just being used in this file. Okay, so if the pipelines is not large enough for that index, then I resize it. I simply resize it after the fact. So this is the have new pipeline that we are calling, and I believe that this is then the pipeline that has the handle and layout, and we are getting the handle, which is a pipeline handle, and then this pipeline has both the pipeline factory index, which gives us all the pipelines, and now we have pipeline index that is apparently needed for the factory pipelines, and as you can take this as true. We resize the thing and now we use it. And then the only other place where it is being used is here. Simply get the handle of a pipeline by pipeline handle. So my conclusion is, since the resize is being done here, I do not need a maximum pipeline value. That was a lot of time just for one comment, FIXME. But yeah, you want to be sure, right? Now, of course, there is a limit. There is some limit. A limit could be that we run out of memory, of course. Another limit could be that the shift is a bit too large. I think that we're going to run out of memory before the shift spills over, right? It simply cannot have a lot of pipelines. We can maybe 1 million pipelines, but we cannot have 2 to the power 64 pipelines. That's not going to work. I'm not feeling very certain about all of this at all. I mean, the whole design seems a bit... I keep supporting these characteristic ranges, but it's starting to feel like it was an error. Anyway, didn't edit here or anything, so let's just go out of it, and then I'll have to rename all of it back, so we go back into it. Rename the pipeline index 2 back to Nightbot. Nightbot has to wake up again. It's not waking up. Yeah, there it is. For 5 seconds. I'm getting so sick of this bot, it's unbelievable. Yeah. I put this in, that's being used in the name. If you ask me, it's the name of the bot, right? Check the username. So If it's the name of the bot, it should cancel. It should kick them out. But it should kick them out for 600 seconds, and it's using 5 seconds. God knows why. But not. It's apparently not because they have a blacklisted word in the username. Nightbot is not working. We have to write it ourselves, it seems. And of course, Nightbot is not open source. I hate fucking things that don't work. Just if you write this and you make why is it not working? Ridiculous. 1, this should be open source. 2, I should be able to run it locally, but no, someone is running it for me. I don't want that. I had to give all my credits, all my YouTube credits to this bloody bot, and it's not even doing the right thing. Pissed off. So no, it's not needed. Throw this away, then we don't have to call this line, and this can be deleted. Never. I have no deadline. I have no plan. I just work. Should this shouldn't exist. I added this for the sake of UBT to get the texture binding in creator. That probably should not exist then. What is it? This shouldn't exist. I added this for the sake of uniform buffer test to get the texture binding in create uniform buffers. So I guess it's not even used anymore. I don't know, man. I don't know. But possibly. It's just too much work for one guy, so that's why. If a lot of people would join in, and then maybe we would get it to finish. But apart from having a lot of subscribers that are just starting to learn C++, or I don't know, people like my voice as a background for their own work. I haven't been contacted by a lot of people that want to. There actually were 2 people who said, okay, I'm going to try to compile it. And they were happily left off, and I made a special channel on Discord so where they could post their problems. And I said, you know, I don't think you will be able to do this alone. You're going to have to get my help. So please, any error you run into, paste them on Discord, and I will personally help you over every compile problem. I never heard of them again. Never. I don't think I even saw them again in the chat. So what happened to those people? I don't know. If anyone, one of them, I remember only the nick of one of them, and then his nick was just D. Just a single character, D. So anyone sees D, ask him what happened. That he tried to compile my project, and then we never saw him again. What kind of disappointing. Well, A45, to be honest, no, because you have less than 10 years C++ experience and probably no 3D graphics experience. And you're also a noob at Vulkan, but feel totally free to begin with compiling my project. It's on GitHub, see the description. And, well, if you manage to do that, then that won't be the first step. I would say just begin. Okay, so I want to know if this is even being used. Well, you know the drill by now. Rename bindings to, compile. Hello, H. Rudvik Bandekar, and I'm going to pronounce it like that because how else? I might as well start to pronounce nicknames in Dutch. Rudvik Bandekar, yeah, in Dutch. Is it really true that YouTube demands you to have a unique username? I mean, billions and billions of people on the planet all sharing the same YouTube, and then your nickname has to be unique? Absolutely insane. And here I was thinking I renamed all of them back. Then why does everyone has a completely unpronounceable nickname? But I do force you to use ASCII, right? I mean, I'm completely pro that everyone is talking English in the chat. I mean, you know, one world. Got to pick one language, and apparently it's English. But, well, I don't know. Let's not talk about politics. Getting sick of the world. It's better to concentrate on happy things like programming. Yeah. It did compile. That's not possible unless, of course, it was indeed not used. Should this exist? Well, maybe not, because it's not used anymore. None is bindings even used, you know. And the bindings used here, it's private, thank God. We have a binding and we have an M bindings, which is apparently not used. And then we have return bindings at, but if it is never set, it's being printed, it's being run over. Okay, it is being used. Or is it? Oh, here's being assigned, update binding. Okay, I'm convinced. And bindings is being used. Well, we don't have an accessor. We do not have the need for this accessor. Hello, Boton Barabas. Good day to you, sir. I'm good. Six. I mean, Just 66. Nothing is wrong yet. Finally, we are at the 600 seconds. It seems weird to call this here because create vertex buffers should only be called once. Let's have a look at that one. Oh, right. Yeah, that's not just weird to put it here. It's just weird to use the the whole assert thing's a bit weird. So this is calling create vertex buffers, and the comment says, why on earth are we calling this here? Because obviously we should only create vertex buffers once, and the current function is part of a pipeline factory. That's what it says. Okay, so the current function being initialize. Yeah, that's definitely weird. It's even calling something unrelated to the pipeline. Or is it? No, it's not really unrelated. It's passing this pointer. Create vertex buffers. Let's have a look at what that does. This member function only uses vertex buffers, which is AI thread safe. Therefore, the function as a whole, I guess, is made thread safe const. Only. Yep. Okay, so what this does is it runs over as a for loop here. This calls something. It does definitely passes a characteristic range even. Yeah, I don't know, man. What shader input data? Characteristic range just passes that on to the owning factory. This is the pipeline factory. Which is a task. It's not possible to pass the pipeline factory itself. It's also being passed here. It's a data feeder. Make a unique shader builder vertex shader input set feeder. Vertex shader input set, comma, pipeline owner. Input set owner is then set to the characteristic range. Seems nonsensical. Must keep this alive. The input set pointed to by an input set will be owned by the object derived from this. I don't think so, no. Simply not true. It says the input set pointed to by m input sets, that's this thing, will be owned by the object derived from this. But m input sets, so now we're going to verify that. M input set is set to the other one. Input set here. At the moment we create a vertex shader input set feeder, which happens to be the shader input set here, which is okay, whatever. Pointers to it are stored in vertex shader input sets. Which okay, wait a minute. Annoying. I have to group. Now it's suddenly part of shader input data. I mean, like, really. But okay, it doesn't mean that whatever it points to is. So I need to know where the objects are that this is pointing to. And we found the pushback. I'm gonna guess that this is the only instance where that happens. At vertex input binding. So that's a pointer to the vertex shader input set that was passed to add vertex input binding. Let me check. It's just We'll run over it here, but that's all. And so who is calling this function? That is now the question. And that's simply the window then. Really? Transformation, void, add vertex, input binding, print it, I'm there's something along with it. These are the main problems. Oh, well. Okay, so M heavy rectangle, for example. M heavy rectangle is derived from... Come on, I want to see that base. Again. Vertex shader input set is derived from vertex shader input set base. And heavy rectangle is derived from that. So heavy rectangle is derived from vertex shader input set base. And obviously so is random positions. It's the same thing. And either of these two are being used to call add vertex input binding, which happens to take that as a reference, but well, I don't really know that. It's at the bottom of this function. So we take the pointer to that. So now we have the pointer to this vertex shader input set base, and we push that back. And the thing is simply owned by the window. There's nothing to keep alive here. I'm a bit confused. Unless, of course, we want to keep this vector alive, which is part of shader input data. There's nothing to keep alive about that. This is not reference counted. So these pointers here point to objects that are have a lifetime equal to the window. That's pretty long, like forever. And that pointer is then passed to the constructor of vertex shader input set feeder. How should I pronounce that? Vertex shader input set feeder, I guess. Yeah, and that remembers then that pointer. So M input set is now pointing to something that is a member of the window. And then, well, the name even says it. Input set owner is a characteristic range. What a bullshit is this? It doesn't make any sense whatsoever. I think I moved stuff around or something like that, but this doesn't make any sense. So yeah, I don't think this is the owner. The only thing I'm doing with it is keeping it alive. Right. Oh, we don't even have a CXX one for that. Now, so what happens if I comment this out? What is this feeder thing doing anyway? Yep, we'll never know if I pursued that direction. Yeah, okay, it's doing something, let's put it that way. It's overriding 4 virtual functions of data feeder. The whole thing should be used somewhere, though. Oh, here, set data feeder. Anyway, I don't think you have the need for a pipeline owner. Well, pipeline owner sounds a whole lot different, I must say. But, yeah. What am I doing? I'm removing FIXMEs. So I have a comment. The comment says FIXME, and then I'm fixing it. Which comes pretty close to I'm sitting here with my eyes closed, meditating, and feeling stuff and following my feelings, kind of randomly. Why does it compile? Okay, the trick is now that this is still working, but we'll never know if what I just did was correct. But hey, until it crashes again, I'm going to assume that what I just did was correct. There's nothing to keep alive. And in the meantime, I've got what I really was doing. So I was working on this FIXME, right? And then I got distracted, or what was it? Well, I was looking at what this even is, yeah. Create Vertex buffers. Okay, create Vertex buffers runs over all the Vertex shader input sets, which were added by the user, I guess. And then we just get chunk size and count and buffer size, and we create a new buffer, I guess. Now get the write log on Vertex buffers. So I remove this comment because I'm not even calling mplace back anymore. What this thing pushes back is I guess memory buffers. Yeah, this thing here. And that is buried so deep that it is not really strange that it has to be passed, actually. Well, if I no, it's not really true. If I have the right lock, I have the access to this type here. And the pushback is simply on the standard vector. And this memory buffer has suppose a clear constructor here. Yeah, well, I could use a try in place. I think this is good enough. I'll just make a I like this more. It's the same thing, but so make a temporary here, and then the temporary is an R value, and the R value then causes us to call I think a pushback with an R value, right? Is that not something that exists? Do we need an in place back for that? You know? I'm not sure. I think we do need an in place back. Let's have a look at standard vector. So pushback also has a R value. Right. Since C++20. No, not really. It's just the const expression was added. You always had a move pushback. So that pushback is good enough. On the other hand, maybe it will create it and we don't have a move assignment or something. It's going to be use assignment, right? Yeah, probably. I have a move assignment. Okay, all is good. Which calls destroy. Seriously? Well. Well, okay, it calls destroy on the default constructed thing that we just put into the vector, I guess. And default constructor doesn't do anything. So this is going to be false, we don't do anything. So it's a pretty cheap operation. Had to be. I mean, it's a vulkan buffer. It's not even a normal buffer. I'm seeing ghosts. Oh, so we are running over all the Vertex shader input sets. which gets a write log on Vertex buffers, and then we push back a buffer for each of them. Got a new buffer. Rather get a handle of the new buffer that we just created. And then we create a task called copy data to buffer here. And we set a resource owner on it. Now this is the window. Wait for this task to finish before destroying the window, because this window owns the buffer, not just the buffer, right? Also the vertex input sets. Maybe that's not clear enough. You know, later I might revisit it and then don't understand it, of course. Not enough space to add comments here, though. It starts to be a bit long. No, there is no add vertex buffer. Oh, that's what it was. Add vertex input binding. Let me just do it like that, the whole line. The user should call, for example, or every rectangle is an object owned by the window. Oh, that's enough. Erase everything, reformat your hard disk and start from scratch, and don't click on it again. You can also install Linux. I've never been any virus or whatever, I don't know, just safe Linux, no problems whatsoever. So yeah, well, my guess is that this uploads, this generates also. Probably. It uploads vertex buffers, right? Yeah. And we should do this once per window. The problem is that we cannot do it too early and we cannot do it too late. Which is why I'm doing it here. That would be the right point to do it, apparently. Why can we not do it sooner? Is that a good idea? Or is that a good question? I have no idea. Let's try to compile it. We compile it. Let's run the tests. This one works. The other one works. And now we're going to... what was the last file I was in? Oh, this is the last file. What about I'm just not calling this? Just to see what happens, you know. Frame resources count. Okay, so it's only the FRC thing that will stop working. The other one still works because nothing was changed to it. See, this one still works. FRC, however, crashes. Totally expected, isn't it? So this is needed. We should do it only once. I have the feeling that it's already only being done once. Will I ever see it when I do it twice? No, I don't think so. Just going to upload it twice. Maybe override stuff. Okay, I'll just test it. So we call it twice. I don't really expect anything special to happen. So you have to avoid that. It did. Okay, it does core dump, so that's nice. So we can check if it is called 0 times, it's no good. Called twice, no good. If it's called once, then it is good. This one worked. Okay, now I want to know where we are being called from. Oh, actually, now I know that it's not only going to be called once anyway. I might as well delete this. That's not necessary, is it? And this fixing is going to be removed eventually. I really need to figure out where this initialize is being called from. Well, I know it's being called from the factory, pipeline factory. So I'm not going to call this at all here. I'm just going to find out where this initialize is being called from, and then let's call it from there. But, well, we have to stay inside the window.h, I think. Seriously. That's still inside initialize. We might even not have. We might not have a pipeline factory. Of course, we have a characteristic. Here it is, pipeline factory. I was searching for capital pipeline factory, but it's simply called lowercase. So what I could do is call it before we even create the pipeline factory. And now we're inside Windows, so I might as well do it like this. Oh, we have this pointer. What was that? What's that about? Pipeline owner. Oh, but we didn't use it anymore, did we? Well, I got rid of that. No, it's using the Vertex share input sets. Now I'm not using it here, but still being used here. Okay, that sucks. Shader input data. Oh, like that. Yeah. What the hell? Yeah, okay, I'm an idiot. I get confused about that more often, it seems. This is M heavy rectangle. And I think this is the window class. But it isn't. This is where we are. This is what I am adding there. And that is a member of the frame resources count pipeline characteristic. So everything I did in the last half an hour was nonsense. We do need to keep the characteristic alive. It's not part of the window. It was all nonsensical. I'm going to revert it. Let's do a get restore -p. Let's see. Get add -p rather, apparently. I want this, yes. I don't see the change. These two lines, aren't they exactly the same? Vertex buffers only push back for the memory buffer. Oh, I changed this. Yeah, okay, I can keep that. And then here is the same thing. So let's do a yes. And then here we have copy data to buffer. Let's change to. So I guess this must be reverted. Well, back to this FIXME, yeah. I guess problem is that the usable tutorial doesn't take into account n on m or 1 on n or n on 1 relationships. Tutorials all assume everything is a one-on-one relationship. You have just one of everything, because God forbid you would make a tutorial where the same thing is being used several times. That's more complex. So you get the feeling that everything is a one-on-one relationship, and then when it isn't, and in most cases it isn't, you just have no idea what you're doing when you learn a tutorial. Bad tutorials. In this case, everything I started with just a tutorial code, and by Intel, called Practical Vulkan. Well, not so practical if you ask me. Their example then calls a whole bunch of functions, one of them being create vertex buffers. And since we have only one window and you have only one vertex buffer and we have only one pipeline and we have only one whatever, they can get away with that. There's a whole list of functions that are each called once and all from the same function, one after another. And then they leave it as an exercise to figure out how to split it up in 100 pieces, wind it into 4 loops and add all the one-on-n relationships. In this case, we are now, after I did already a lot of work, of course, we are now inside a pipeline factory. The initialization of a part of a pipeline factory. So I have pipeline factories which have characteristics. Then at the moment the one characteristic of a pipeline is being initialized, we get here. And then as a remnant I'm still calling create vertex buffers. But what is the relationship between vertex buffers and everything else? And to be honest, I don't know. I think, the vertex buffer is something that is uploaded to the GPU. And shaders read from it. And shader is a part of a pipeline. So we have a pipeline with a vertex shader in it, and the vertex shader reads data from the vertex buffer. So that looks like, or smells like, feels like a one-on-one relationship. But that's definitely not necessarily the case. We could have multiple pipelines using the same buffer. So either each pipeline has its own vertex buffer, or maybe some vertex buffers are shared between multiple pipelines, and that could even overlap, I guess. I don't see a really good picture here. I can imagine that we have like 10 vertex buffers and 3 pipelines, and everyone uses each other happily. It's a vertex buffer orgy. But when does that happen? I cannot picture this, man. I'm still not even sure how many pipelines I'm going to need and when and for what. The best idea I have is that the pipeline is required at least for different materials. You can definitely use the same pipeline to draw different objects. Say you want to have I have a pipeline for making metal looking stuff. Okay, so keeping the idea that this material thing gives me a clue. I could have a pipeline that is capable of making metal. And then I can have multiple objects, and an object in a 3D world, that's a bunch of vertexes. So I can imagine that, say, I have a metal sphere and I have a metal cube, and they are just completely different objects in the sense that the cube is bouncing around at the horizon, and the sphere is rolling over a surface closer to the camera. So those vertexes are not really related, even though those things are both made of metal. So then I can imagine that we just want to use 2 vertex buffers, one with the vertices of the sphere and the other with the vertices of the cube. However, if I want to see, I can use the same pipeline because, well, it's both metal. They look the same, just the vertices are different. So in that situation, I would have one pipeline that is reading 2 different vertex buffers. One after another even, I think, because they're not connected. I'm not sure how that really works. Maybe you can record a command buffer before I start the pipeline that draws both objects. In which case we have the 2 vertex buffers being used by pipeline in one go. That might be more efficient instead of running pipeline twice, of doing 2 draw calls. But the relationship remains that I have one pipeline and 2 vertex buffers. Now, on the other hand, it would say it is possible that my vertex buffer, which contains just vertexes, which is, for example, a sphere, and I have a wooden sphere and a metal sphere in my scene, and those are different pipelines. I mean, there can be many reasons that you have different pipelines, so that's not too hard to imagine. And then it's the other way around. Then I have 2 pipelines and 1 vertex buffer. And in that case, I want to feed the vertex buffer to 2 different pipelines. Now my create vertex buffers, okay, I wrote this. It's a plural S. It creates multiple vertex buffers, and not only creates them, but also uploads them to the GPU. I think that if I have a sphere and a cube, and I have them in different vertex buffers, then I just need to generate them once, and I need to only upload them once to the GPU. So this code that you see here is of course running on my CPU, and it's really the copying here that is being done that sends stuff to the GPU. I only want that to be happen once, right? So at this point, what is happening here is not related to any pipeline at all. It's pure vertex buffers. I do have a for loop, but that runs over, say, the sphere and the cube. So we're going to have a sphere and a cube, and then we do this for the sphere ones, and we do this for the cube ones. There is no metal or wood or anything. The material, etc. is not into play here. This is just vertices. So the pipeline is not relevant here. I'm just thinking out loud. Which means that the generation of the vertices and the upload can be in one function, as I have done it here. In fact, the generation is done by this data feeder. Maybe even this thing here, the Vertex shader input set feeder, that actually generates the coordinates. And it's being sent to the GPU without buffering. I mean, I am a speed freak, I know, so it generates it and then it copies it immediately from generation to the right place, from where it's still in the CPU. But then, CPU, it's just PC CPU side. Yeah, you have to copy it somewhere, but I really don't want to, call something that generates the coordinates and then move it to a buffer which can be copied to the GPU. So I'm generating directly into the space that is going to be uploaded to the GPU. That's why it is being coupled like this. But that should be okay. That is a one-on-one relationship. So the generation, okay, each object contains the information of how to generate the vertices, the sphere or cube. And it's going to generate that and upload it to the GPU. Bang. And then what do we have? I think we have a buffer then. This is then it's a vulkan handle to a buffer, and the buffer contains our data on the GPU side. That's why it's pink. And I really want to do that only once per whatever we run over here. Okay, so far so good. Now the problem. There is a pipeline here. What's the pipeline doing here? Well, it's the owner of the pipeline, but still. This type is characteristic range. Is even a part of a pipeline? I don't know. Nobody understands this. And just a minute ago, I said that this should have nothing to do with the pipeline. I think the shader input data has a lot to do with the pipeline. Pipeline contains a shader and input data for that shader. Okay. So I'm telling the pipeline that it has to get ready to read a certain input. And I'm doing that by adding for this pipeline the object that is responsible for generating the coordinates of the vertex thing. That's not correct. That should be done somewhere else, separately. It feels like there has to be, let's say, if I already did this, I would simply have this buffer handle, and then I could just say, your shader input is equal to the data that you can read from this buffer. And I can do that multiple times to multiple pipelines with hardly any extra cost, because it was already uploaded. So I think I'm going to have a pipeline factory that needs a buffer with the uploaded data, but not necessarily also that the pipeline factory itself is not really responsible for generating and uploading that buffer. That's not possible because it might happen. It's basically only needed once, while multiple pipelines might need it. So then, if I go back, at this point, I'm defining the pipeline, right? So I'm saying, okay, you're going to read input data, and that input data is generated, that it's a vertex, so you're going to read vertexes from this object. It's also going to read a texture, it's going to read the push constant. I'm defining the input that is needed, or that is, that will be needed by this pipeline. That the pipeline is going to use. And that's okay, because it is going to use this, but it's the way it's written now. I still need to generate the heavy rectangle coordinates and upload them to the GPU. And I want that to only happen once. Okay, but this M-heavy rectangle object is currently an element of the characteristic, which is possible, you just... Why would I make this an object that is a member of, say, the window class, if only this characteristic would be using this? On the other hand, the vertex, a bunch of vertexes, is normally not part of a pipeline at all. It doesn't really belong here. It doesn't belong, no. Let's say it says heavy rectangle, but let's keep using the cube and sphere thing again. Let's say this is my cube and this is my sphere. And then why are those part of a pipeline characteristic? Because, that just doesn't make much sense, I think. I think I have to rip them apart. There are objects that generate vertex coordinates, and there are objects that generate pipelines, and they must live a separate life. And then at some point I can connect them by saying that the output, the vertex data that was created by one object, is going to be read by a certain pipeline. And then I can link them in as an N to M relationship. I can link any number of vertex generating objects to any number of pipelines in any way. That's the objective, I think. Now, before I can use the pipeline, where use means drawing to it, really make use of it, I guess, in the render loop. Yeah, well, is that true? Single pipeline, yeah. I mean, a pipeline is something that runs on the GPU. So by the time you say draw, you run the whole pipeline. And that pipeline is then going to expect all the input that you told it that you're going to give it. You cannot say run the pipeline, but only partially. So the pipeline is finished when you can run it, and you can only run it when all the data that you promised that you would give it is there. So the pipeline then is only finished after all the vertex generating objects finished with generating and uploading. So we was all the way to the handle, the buffer handle, that I think is the only thing that eventually you really need on the pipeline side. I'll have to check that. Would be a good thing to check next, I think. What exactly is needed by the pipeline to make use of this vertex stuff. I think just a handle to the vertex buffer. So, and then the other object, and that's then going to be a task, is a task that generates the vertexes and uploads them to the GPU. So the heavy rectangle must be a task, or a characteristic of that task anyway. Post Bunny has become a moderator. Hi, Post Bunny. So the other day someone called you a girl. Are you a girl or a boy, Post Bunny? Or is it not allowed? Oh, yeah, now I'm going to talk politics again. Let's not talk politics. You're a woman, okay. It's almost dinner time again. Yeah, well, one FIXME, but a lot of work ahead to separate those two, but it's a good step in the right direction. It's not bad to know what to do next. Let me have a look at what I just said. What the pipeline now is really needing from a call like this. Let's pick the heavy rectangle. Because people don't understand it. I think that the heavy rectangle here is defined like this. Comes with a lot of ports. Just comes with some nice ASCII art. See, so this is the heavy rectangle object, and it will generate vertices. And I even added a nice ASCII art documentation here. To explain how this works, it's simply a rectangle. Well, this is a square, but the size for x and y can vary. X runs from 0 to actually this looks like a square, because x and y both run to I side. Okay, so this integer side is 4, then we have 1, 2, 3, 4 squares, and vertically as well. And each square is divided into 2 triangles, so in total this thing has 32 triangles. And the vertices are created as follows. X runs from 0 to I side minus 1. So this is 0, 1, 2, 3. And Y runs from 0 to 3. Starting at the top. 0, 1, 2, 3. Which is gives us these 16 points here. Those my mouse is circling around. And then I'm guessing shown are the triangles that belong to x and y is 1, 1. So A here will generate these 2 triangles. So if you run over these 16 vertices, then we're going to, from this corner here, we're going to generate this square, from this corner, 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 this square, this corner, this square, from this corner, this square, from this corner, this square, from this, so basically all 16 squares will be generated from these 16 corners here. And the triangles are generated in the order ACB. So ACB. And then we generate the triangle BCD. Both are counterclockwise, so they face us. Now this is done with some cons expressions. I side is defined. Some other constants. And there it already ends. There is a virtual function called createEntry, which generates batch size vertices at once. Well, we know what batch size is. Batch size is a constant, I guess. It's 6. So we do the 2 triangles all at once. And the caller, the base class is calling this virtual function, then also must know what batch size is. We could just use it. But it can call this function. So it calls next batch, which in this case always returns 6. And then the caller knows that if it calls create entry, or it calls next batch, get 6, and it knows that if then it calls create entry, 6 new vertices will be created. So this line allows for a lot of flexibility by just overriding a few virtual functions. And you can generate a lot of stuff. In this case, simply a square, but you can also make a sphere or anything like that. And that is then, for the rest, handled from the base class. So this derived class really only handles the vertex coordinates. It's just doing some mathematics. And in order to know what is being done with it, we better look at the base class that is calling these virtual functions. Now let's have a look at the Vertex shader input set. So rather small class. It also has overridden something because it's a template and I did not want to put a lot of code into it. Next batch has a default value, but we did override that in the most derived class, so that returns 6. If you don't override it, it by default returns 1. This has to be implemented because it's pure virtual and was implemented in the heavy rectangles that we just looked at. Here's another one that can no longer be overridden by the derived class. It's just this is the final version. And it does call the other virtual function here, create entry. So the only thing that this thing is doing is adding this cast. It gets a chunk pointer as an unsigned character and then it casts it to entry, because of course only this template knows the actual type of that thing. So the real workhorse is then a non-template, is the base class of this thing, which is derived from data feeder and also very small. The only thing that this thing adds is a vertex input rate, because you have per vertex and you have per instance rates. And both are supported. You can have even an accessor for it. But the real work then is done by data feeder. Which in the header only declares all the virtual functions that it uses. So let's look at the TXX file. It does not exist. Oh, that's great. Okay, this doesn't do anything. We have to look at code that actually is using data feeder, I guess. So apparently there is some code that is using the data feeder, and then that's calling these virtual functions, and it's only dealing with coordinates. Still, it does explain, however, how this is supposed to work. You should call data feeder chunk size, and then you get a size, and then you should call chunk count, and we get a count. And then have a variable next batch, and then we call make a for loop that runs over all the chunks. Then we set next batch to the whatever is returned by the data feeder, next batch virtual function. So in our case that was 6. then we prepare to read next batch times chunk size bytes. So we have a pointer to memory that's large enough, and now we call get chunks on that, passing that pointer on the data feeder. And then chunks must be incremented by whatever next batch was. So next batch value can change every time per chunk, if you want to. So what this really does is just simply write to memory. So this is going to be our buffer, which is then must be uploaded to the GPU. Okay, I'm curious then which code is using this. And that code will kind of look like this, I guess. So it's going to call, for example, get chunks. So I'm going to find that code. Oh, there's one. And that's it, I guess. These are comments, declaration. Yep. It is only being called from the copy data to GPU task. So a task is something that is run by one thread at a time, and it can stop in the middle of execution at certain points without blocking. And then it runs more or less from top to bottom. So we begin at the start state, which gets a logical device and then uses the logical device to create a staging buffer. And now we go to the next state, the write state. And this is then that code. So the staging buffer that we just created is a certain type here. That's going to be suited to write to and then upload that to the GPU. It's probably memory that is writable by the CPU and readable by the GPU. So get a pointer to that, and now we do what we have to do. Call chunk size, call chunk count, and run over all the chunks one by one. I'm calling next batch chunks here. For the rest, it's the same code. DST is the pointer to where we are writing. So after having written to DST chunks times chunk size bytes, then we just advance the pointer with that amount, and then the next chunk writes after the previous block that we wrote. After all of the memory is filled, we're going to copy data to GPU flush. Next state. So far the task just running from, it's just falling through, so it's not halting at all. Here it does halt, so here we break out the switch, which causes us to leave the function. Let's see how that works. So after having done that, we want to flush the written data to the GPU. Which is apparently is done by calling this function, passing the allocation that we made, say that we want to flush everything. I think that now a small program is going to be run on the GPU that copies this data. And in order to execute that small program is we need a command buffer, but that's being done for us. We can just call setRecord function, and then we'll pass a lambda here, which the lambda will be called, and we will be passed a command buffer, and then we have to record the command buffer, which is done by the function record command buffer. Ta-da. So we can jump to that, see what that does. So this copy to data buffer has a record command buffer function. It's almost a page. And then it does some magic with memory barriers and pipeline barriers, and then VK buffer copy region, and then we call, or we record to the command buffer that it must copy the buffer. And then we do other synchronization stuff again, and then we're done. And then after this function returns, the only thing we did was record the command buffer, but that will then be executed on the GPU, of course. So this lambda is being called. We've recorded the command buffer that says we want to copy our allocated staging buffer to the GPU. And upon return from this lambda, it's going to execute the command buffer. And then we don't know anymore, so what we do is we set the state to immediate submit start and do a break. By having set the state to immediate submit start, we are actually going to execute the state of the base class task. So we have to go to the base class of copy data to GPU, which is immediate submit, which is a task in itself, which has immediate submit start state, which is then being executed. So we're continuing at this point here. Okay, so what that does is it passes on the immediate submit thing. So that's probably our command buffer with some stuff or whatever is needed. And it waits until that is finished. So by the time it gets, and then this thread just exits and goes back to the thread pool. But as soon as then this immediate submit finished, we get signaled. We get a signal, and then we continue running the continue state, mContinue state, which I don't know what it was, but was probably set to finish. Or did we have another one here? I guess it's copy to GPU done. Yeah, it's being passed to the base class. So that's the continue state after the upload was finished. Which doesn't do anything, it just calls finish, and then the task is finished. Now, it is not clear to me, I must say, how then after that we can access the data that was uploaded to the GPU. I now know that it finished, so it uploaded it, but then How does my shader know where to find that data then? Come on. Just have a look at the command. The copy buffer command basically is telling us to copy. So okay, it seems trivial that the copy buffer copies from the staging buffer to the target buffer. So afterwards, the data is in the target buffer here, and that is a vulkan handle. So this vulkan handle somehow also must end up in the pipeline, right? So the pipeline knows where to find this. And that thing was set apparently when creating the copy data to buffer, or at least it is being set here, which is initialized when the constructor is being called. So we have to look at the constructor of the copy data to buffer to see what that handle is, and then maybe how that handle also makes its way to the pipeline. I must say I forgot where we came from, but trying to find it back. Create Vertex buffers. Yeah, that should be it. So here we have the task, copy data to buffers being created, and these are the arguments that will be used for the constructor. So I think that the new buffer is the buffer that it ends up in, which is this thing here. Which is what was added to Vertex buffers. So we are copying our data to a buffer, GPU side, which has a handle that was stored in Vertex buffers. And then this is the render loop. Here we are recording the command buffer that must be executed every frame. And this is inside draw frame, so this is called every frame. And it takes a read log on Vertex buffers. And then gets Vertex buffer container type reference from that. And then we call bind Vertex buffers. So that's how the pipeline knows. Pipeline was already bound. Okay, so recording of this command buffer works as follows. The pipeline is being bound. So this is my way to store a pipeline, and then in order to get the actual vulkan handle, I have to call the member function handle and then pass that through vk graphics pipeline function, and then we get the corresponding handle of the vulkan handle of the pipeline. But okay, it's just the graphics pipeline. Only have one pipeline in this test application. So we bind the only pipeline that we have, and we bind the descriptor sets that we have, which comes from the pipeline itself. Also, my pipeline also knows which descriptor sets it uses. And then we bind the Vertex buffers. And then we set the viewport, set the push constant, set the syssource, and then we call draw, which basically means we run the pipeline, passing the number of vertices and stuff like that. So then when the pipeline is being run here, it has per frame all the data, and among which, well, rather yeah, I'm kind of confused here about the fact that even the pipeline is being bound. So you would, what it really do is run the command buffer, right? So this is a little program that is running on the GPU. You can even bind, you can even continue to bind a different pipeline after this, and then execute multiple pipelines in one command buffer. In this case, we just bind one pipeline and we do one draw. So the whole command buffer executes a single pipeline. But okay, what we really do is then we run the command buffer. So this is just a recording of the command buffer. And then at some point we really run it, I guess here, submit. And then the GPU, then the command buffer is being uploaded to the GPU, and the GPU is going to execute all the commands. So it's going, the GPU is then, after the submit, we're going to execute the bind. We are going to bind the pipeline and bind the descriptor sets and bind the Vertex buffers and etc. Right. So our Vertex buffers that we use really comes from, well, whatever Vertex buffer is here. Well, that's this. That is this, which is Vertex buffers is a object that is a member of the window.h. Now I have the feeling that see that, well, the pipeline, I would almost say the pipeline, whatever that is, can be reused, can be used with any vertex buffer. So the pipeline really does know nothing, doesn't need to know anything about the vertex buffers. We're just going to say, hello, use this vertex buffer, and that's the number of vertices that are in it. So we can use the same pipeline to draw the sphere and then draw the cube, even within one command buffer recording. We just do bind pipeline, and then we do bind vertex buffer, buffers, whatever, and then we do a draw and draw a sphere, and then we do again bind another vertex buffer and do again a draw, and then we draw the cube, all while having the same pipeline bound. So I take back my my previous remark that the pipeline can only be finished at the moment that we have this data. That's not true. A pipeline can already be finished when we don't have any vertex buffers at all. It would just be a mistake to start execute this code, bind our pipeline, which is finished, and then come to the conclusion that we cannot record the command buffer because oh yeah, right. So maybe I should, and I think I saw someone at some point make this remark also. He said something like, it's easy to do the recording of your command buffers in an additional thread, and in my case that translates to a task. So I could make, say, the whole recording of a command buffer a task, and then that task would be finished once both the task that creates the pipeline is finished, so we can bind it, as well as the task that creates the vertex buffer is finished. And then we can run that task to record the command buffer, and then only once that task is finished, we can insert the command buffer in the random loop. It's maybe kind of confusing idea, but why not have multiple command buffers be executed, submitted? Nah. Yeah, well, I don't know. I would have to ask that to a few real goers that know how Vulkan works, or rather how to code graphical applications. What the typical number of command buffers would be that you execute. I can imagine that it doesn't really matter though, but well, until you make it too crazy. But I can also put everything in one command buffer, I think. Where does the command buffer come from? Here. That's a frame resource. Yeah, well, that feels like if you come here, there's for a given frame, you just get a command buffer. I currently only have one command buffer apparently per frame resource. Vulkan is an API, so it's open, but it's not. Yeah, well, it's basically open source. But the drivers are not, of course. Not all drivers. Most drivers are not. Command buffer. Okay, what I could do is just get my single command buffer for this frame, and then record to it in batches. So I would just record something until that thing is done, and then the next one, and the next one, and the next one. And that would, for example, mean that I could record a command buffer that just puts together a whole scene. Let's say we start binding a pipeline that can draw metal, and then I would bind the vertex buffer that is a cube, and then we would draw the cube, and then I can bind the vertex buffer that would draw a sphere, but in a loop, more like not being part of the same function, but more like in a loop that belongs to the metal thing. So yeah, I'm getting a more clear picture of how this is going to work. Very complex, that's for sure. Not really finished with this engine yet. It's not flexible. It's not powerful enough the way it is now. It's just still hard coding what you want to do. Only one thing is possible, and that's not good. There's also a FIXME here, of course. It's not for nothing. And here. But the big takeaway is that I definitely need a separation between creating my vertex buffers and the pipeline. I think I'm going to have to think about this without sitting here and talking into the microphone. I can really lay down, say, and then just think for an hour or 2 hours before I get an idea. That would be too boring to stream. I need to have some idea before I can start typing again, right? Otherwise, if I would just say, well, I cannot think, I have to continue typing, then I might start doing nonsensical things. I need a better picture in my head. What is the next step? Plus, it's already dinner time, so I'm going to end the stream and then cook me some dinner and eat that, watch a movie maybe. And at some point I'll start thinking about these new ideas, how to approach it. Oh my god. Post bunny. No, seriously. Anyone did message you on YouTube? I don't think that's even possible, is it? No. Okay. Well, because if they were, that would be a scammer. You know that, right? Where was I last hearing about that also? It's more a Discord or Telegram thing, I guess. I mean, if but let's use it's not possible, but yeah, okay, it was an email. Even emails, you know. Anyone who contacts you is potentially a scammer. Do not give them any personal information. Why would they send you an email? I mean, I would be very careful. You have to be 100% sure that they are legit. So you could ask for the phone number and then verify the phone number and then call the reception, maybe even go there and see that they have a building and everything. Before, if you just say, oh, I get an email, I'm going to send them my full name and my address and my social number and stuff like that. Yeah, that's not a good idea. Okay, yeah, well, that's of course always safe. Just don't give any information on over the internet, email or otherwise, because that's being abused so much that by now no legit company would ever even ask you information that way. So you can almost be 100% sure that if anyone wants any information from you by email or even in social media, which would completely ridiculous, then it's going to be someone who is going to steal something from you. Yeah, I don't know. So sometimes, I mean, mostly I think I'm not smart. I feel stupid a lot. But I've done certain things in my life that when I look back, I think I can only conclude that maybe that was smart. For example, from the very, 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 very beginning, I have not put anything personal online. I think at some point I started to relax it a little bit, but I doubt anyone who, well, no. Well, yeah. I don't know how hard it would be to find my real name. Probably pretty damn difficult. It is indeed on the internet these days. But I never, ever, ever get an email that's using my real name. That is not legit because only, let's say, my bank knows my real name, and when they send me an email, they start with dear whatever or hello whatever, and then they use my real name. And just the very fact that they know my real name already makes it very unlikely that it is a scammer. Because it's nothing you can find nothing online about me. I even use it as one of my main spam filter things. So I have an extremely fascist spam filter thing that's massively aggressive. But if an email contains my real name, then I'll let it through. And indeed, it's never, ever spam. It's always legit when that happens. So that's kind of cool. Okay, I was going offline, right? I'm going to eat.